Good morning, children. Today, this is ninth physics. Today's topic is topic 10 of chapter number 8, motion. And topic is equation of motion. So, children, by the end of the class, you will be able to define the three equations of motion. You will be able to derive the three equations of motion, right? Let's see the first equation of motion. The first equation of motion is V equals to U plus AT. This equation has a name, that is velocity time relation. As you can see, your capital V is final velocity, U is initial velocity, and T is the time, right? So this is your velocity time relation, velocity time equation. Let's proceed towards the second equation of motion, that is S equals to ut plus half at square. Now your S, it is the distance covered by an object or displacement, right? And your T is the time taken. So this equation is also known as position time relation. The third equation of motion is 2as equal to v square minus u square. So here A is the acceleration, S is the distance, V is the final velocity, and U is the initial velocity. So as this equation gives the relation between position, that is your distance, and velocity. So this equation is named as position velocity relation. Okay, so let's start with the derivation. Let's start for the equation number 1. So here for the derivation, children, we have considered an object which is moving with uniform velocity, right? So if you draw a velocity time graph, velocity on y-axis and time on x-axis, for uniform acceleration, you will get a straight line graph, right, beta? But as you can see that the graph is not starting from origin. If it is not starting from origin, what does it mean? It means that its initial velocity is not zero. Initially, it is having some velocity. And so the graph is starting from point A. A is the initial point of the graph and B is the final point of the body, right? Now, here you can see in the equation that OA, it represents the initial velocity of the object, and OE, it represents the final velocity of the object, right? So initial velocity is U, final velocity is V. Final velocity is at point B, right, beta? And the time taken for this change, that is from initial U to final V, is small t, and that is OC. As you can see here, it is O and here it is C, right? And acceleration involved here is small a. I hope this much is clear, right? Now, children, we will be doing two constructions in this. The first construction is from the final point B, you have to draw two perpendicular lines. Firstly, you will draw a perpendicular line on the x-axis, that is BC. So BC is the perpendicular line from point B on x-axis, right? This is the first construction from B. And secondly, you will draw a perpendicular line on y-axis from point B, and that line is BE. So draw BC and BE from point B. They are perpendicular lines on x-axis and y-axis respectively. Got it? Okay, this is your first construction. The second construction is beta from initial point. So from initial point A, you are drawing a perpendicular line on BC, right? Line is you are drawing AD, which is perpendicular to BC. Or you can also say that this AD is parallel to OC. That is also one and the same thing, right? Now, children, if you look at the picture, at the figure very carefully, then this is a rectangle. And we know the opposite sides of a rectangle are equal. So children, if this is U, this is also U. है ना बेटा? Okay. And if this is T, if this is T, then this side is also T, right? Okay. One more thing we can see from this, and that is the bigger rectangle. That is OEABCO. Now, this side is V, right? So opposite to that, that is your BC will also be V. Yes, BC pura kya hoga? V, right? So we can write this entire thing, that is BC is V, right? Similarly, this will also be T. Okay, this will also be T. Yes, sure. I hope this much is clear. Okay. Now, children, we are going to start from the graph. From the graph, children, you can see that this entire line, that is your BC. Can you write BC is equal to BD plus DC? Yes, we can write. Okay, we can write BC equals to BD plus DC. Now, your DC is nothing but, as you can see, this DC is U, which is nothing but that is equals to OA. This OA and DC, they are equal. So instead of DC, here we are substituting OA. So BC equals to BD plus OA. This is equation number 1. Now let's substitute the values we know in this. We know the value of OA. OA is U, right? We know the value of BC even. BC is V, right? So let's substitute this value of BC as V and OA as U in equation number 1. So we will get equation that is V equals to BD plus U. And if you make BD subject of formula, you will go that side, it will become minus. And so you will have BD equals to V minus U. Children, till this point, till the second equation, the derivation will remain common for all the 3 equation of motion. Any equation of motion is asked in exam, you have to do till your equation number 2. So this part will be common for all the 3 equations. Any of the 3 equation of motion is asked, you have to do till equation number 2. And then you will change according to the question asked, according to the equation asked. If first equation is asked, then you will do this part, right? And if second equation is asked, then you will do this, upper part. And if third equation of motion is asked, you will do this third part. Got it? So till equation number 2 will remain common. Now we are deriving equation number 1. So we know that velocity time graph, we can find out acceleration. How we can find acceleration? Acceleration formula we know. Acceleration is change in velocity upon time, right? Change in velocity. If you see this, that is change in velocity from the graph. If you see, then this is your graph, right? That is change in y coordinates. So that will be BD upon change in x coordinates, that will be AD. So you're from the graph, you can say acceleration is BD by AD. So acceleration equals to BD by AD. Now instead of AD, we know AD and OC, they are equal. So instead of AD, we can write OC. So we have written instead of AD, OC. So A equals to BD by OC. Now, if you see OC value, OC is what? T. So we know OC is T. So let's put this value in this equation. So when we put the value in this equation, we'll get A equals to BD by T. Let's make BD subject of formula. Then T will go in multiplication. BD equals to AT. This is your equation number 3, right? Now, children, if you look equation number 2 and equation number 3 carefully, then here you are having BD equals to V minus U. Here you are having BD equals to AT. So BD same. So we can write V minus U equals to AT. So we have equated equation number 2 and 3. So if we send U on the other side, it will become positive, and you will get the first equation of motion, velocity time relation, that is V equals to U plus AT. Right, beta? So this is your first equation of motion. Now we are proceeding towards the derivation of second equation of motion, which is known as position time relation. Right? So for this derivation, firstly, you have to do till equation number 2. Till here, it will remain common. Right? After the equation number 2, then you will switch on to the next part, that is this part. Right? Now what we are going to do here, this is position time relation, and the equation which we are deriving, that equation is S equals to ut plus half at square. Right? Now children, we know for position, for velocity time equation, if we find area under the graph, we will get distance. So same thing we are doing. We are using the same concept, that is distance equals to area under the graph. So if you look at the graph over here, beta, then you can see the graph line is AB, and under that, how much area you are having? Under this, we are having this area. And if you see the shape, it is a trapezium. Two sides are parallel and two sides are, these sides are not parallel, right beta? So this is a trapezium. So you can see the name of the trapezium is OABCO, right? So you can write that area under the graph is your area of trapezium OABC. Now children, this trapezium you can split into two figures. ये जो trapezium है, this can be divided as one is rectangle and other is triangle. So I can write this trapezium OABC as equal to area of triangle ABD plus area of rectangle ADCO. I can write, right? So area of triangle, we all know, formula is half base into height. Half base into height. What is the base of the triangle ABD? Base is BD, right? BD. And what is the height? That is, base is, AD, and height is beta BD, right beta? Now AD value you all know. It is time na? Same time, right? So half into time into BD. BD you remember, it is V minus U, right beta? BD is what? V minus U. So let's put this formula of area of triangle in our equation, and we will get area of triangle as half base into height. That is half AD into BD. AD we know it's T and BD was V minus U. This much clear? Area of rectangle OADC. Area of rectangle is very easy. Area of rectangle is length into breadth. So this is U and this is T. So it is U into T, length into breadth, right? Area of rectangle. So here you can see area of rectangle is OA into OC, that is U into T. And so your equation is S, that is distance, equals to UT plus half T into V minus U. Now children, if you see first equation of motion, we know first equation of motion, V minus U equals to AT. Yes. So instead of U minus V from the first equation, here you can write down the reason also. Here we can write the reason why we are doing this. We'll write from equation number 1, V minus U is equal to AT. So instead of V minus U, we'll put the value AT, right? Now let's multiply and see what we are getting. And I think we have reached the final result. That is T into T will be T square. So you are having S equals to UT plus half AT square. So this is your second equation of motion, S equals to UT plus half AT square. That is your position time relation. Okay, beta. Now let's start with the third equation of motion, that is your position velocity relation. 2a square equals to v square minus u square. So for this derivation also, you will be first doing till equation number 2. After doing this much, then you will switch on for this path. Got it? So here what we have to find? Here we have to find again distance. So distance again can be found out by the area under the velocity time graph. We know if you find the area of velocity time graph, you will get distance. So distance equals to area under the graph. And that we know the shape is trapezium. So we'll write trapezium OABC. I hope this is clear. Now children, here we are going to apply the formula of area of trapezium. In maths, we have done. Area of trapezium is what? It is half sum of the parallel sides. Two sides are parallel to each other. Sum those parallel sides into perpendicular distance between these two parallel sides. The parallel distance between the two parallel sides. Now let's see in the graph which sides are parallel and what is the perpendicular distance between the parallel sides. So in this graph, if you see OABCO, this is your trapezium. Now, if you see this side, that is OA is parallel to BC. They are parallel sides. So what does the formula say? Half into sum of the parallel sides. So it is OA plus BC into what? Into the perpendicular distance between the two parallel sides. So I think this side is giving you the perpendicular distance between the parallel sides. So between OA and BC, OC is the perpendicular distance. So you will multiply it with OC. Right? Now, OA is how much? OA is U. OA is, what is the value of OA? U. So instead of OA, we will put U. BC, full, this entire BC. BC is equals to OE as it is a rectangle. So BC is V. Into OC. OC value we can see from here. OC is T. So into T. Into T. Yes, children. So half U plus V into T, right? Now, we are going to substitute the value of T from equation number 1. We remember of the first equation that was V equals to U plus AT. If in this equation you make T subject of formula, what will happen? V minus U. You will go that side, it will become negative. And V minus U upon A equals to T. So this value we are substituting from the velocity time equation, from the velocity time relation, or from the first equation of motion, that is V minus U equals to AT. So we'll substitute this value of T, that is V minus U by T, right? So T equals to V minus U by A. Okay, let's put this value over here. So you will be having half U plus V into V minus U by A. Here you are having distance, and distance we are representing by S. Okay, now children, in maths you have done the formula, that is A plus B and A minus B. A plus B and A minus B can be written as A square minus B square. We know this identity, right? So here also similar to that is there. That is V minus U and V plus U. V minus U and V plus U can be written as V square minus U square. So same thing is what we have done. That is V square minus U square, right? Upon 2A. So this 2A, we are sending it with S as it is in division. It will go on the other side in multiplication, and you will be having the final equation, that is 2AS equals to V square minus U square. So children, these are your 3 equations of motion and their derivation. Okay, children?